All right, so today's lesson is Module 3, Section 5, and we're going to complete the square for a quadratic equation, and then we're going to solve using square roots. We'll have some that maybe have a complex solution, some that won't. Again, yesterday you did a great job completing the square, did phenomenal on that, so I think today we're just going to extend it a little bit. Slight modification to what we did yesterday, but overall I think we'll have a lot of success with this lesson. Our steps are going to complete the square. We're going to write in vertex form, and then we're going to solve by taking the square root of both sides of the equation. So again, you're going to do much of what you did yesterday, and then the day before when we started looking at solving using square roots. So we're going to combine really a couple lessons from this module to come up with a solution. So looking at this first equation here, we have x squared minus 8x plus 7. And we want to complete the square here and then solve it. So unlike yesterday where we had our equation and it was equal to 0 or equal to y, we're going to make this equal to 0. The first thing we're then going to do is we're going to subtract 7 from both sides. And we're going to get 8x squared minus 8x. We're going to draw our blank in. And that's going to be equal to negative 7 plus some number, which is a blank there, or minus some number for that matter. Okay. Now, if you'll remember, we're going to take our b term, our minus 8, and we're going to divide it by 2. I'm going to do that over here. So minus 8 divided by 2, that's equal to negative 4. That means my perfect square is going to break down to x minus 4 quantity squared. Okay. Now that we have our negative 4, we're going to take our negative 4 and we're going to square that quantity. And when we square that quantity, that is going to be equal to 16. In order to complete the square, we must have x squared minus 8x plus 16. That is a perfect square, and its factors are x minus 4 quantity squared. I've added 16 to this side of the equation, so I need to add 16 to this side of the equation. When I do that, my negative 7 plus 16 gives me 9. Okay. Now, to complete to write this in vertex form, we would subtract 9 from both sides. When I subtract 9 from both sides, I cannot subtract it from anything inside the parentheses, because they're not x minus 4. The quantity is x minus 4 squared. So I'm left with x minus 4 quantity squared minus 9 is equal to 0. This is my vertex form. So my vertex form here, again, is x minus 4 quantity squared minus 9 is equal to y. That is my vertex form. We're going to go back to y here for a second to write the vertex form. But in order to solve, we know our quadratic needs to be equal to 0. Our vertex then is the opposite sign of what's in the parentheses. So that would be positive 4. And it's the same sign as what's outside of the parentheses, negative 9. Again, I can confirm this if I go through on my calculator, plotting both y equals for x squared minus 8x plus 7 and y2 as x minus 4 quantity squared minus 9. When I do that, the y1 and y2 values will be the same. Our vertex is 4, negative 9. It's a minimum. Now, to solve, we have our equation equal to 0. So what we are simply going to do is x minus 4 quantity squared minus 9 is equal to 0. I'm going to move the 9 back over to the other side here. And what I get is x minus 4 quantity squared is equal to 9. Now, at that point to solve, I'm going to take the square root of both sides of the equation. When I do that, I end up with x minus 4. And just so we know that we're solving here, I have x minus 4 is equal to plus or minus the square root of 9. Now, fortunately, in a problem like this, the square root of 9 is equal to 3, so I'm going to have plus or minus 3. I have x minus 4 is equal to plus or minus 3. I'm going to add 4 to both sides now. When I do that, I get x is equal to 4 plus or minus 3. Notice I didn't combine those into one term yet because I really have, because of this plus or minus. This could be positive 3 or negative 3. So what we're going to see now is I'm going to split this into two potential equations. X is equal to 4 plus 3, and x is equal to 4 minus 3. Of course, that's going to be equal to 7. That's going to be equal to 1. So x can be equal to 7, or x can be equal to 1. At this point, for my solution, I can go ahead and plug in 7 and see if that gives me 0. 7 squared minus, it would be 49, minus 56, plus 7 would be 0. So that answer is going to check out. If I look at it from x equals 1, I get 1 squared minus 8. So 1 squared would be 1 minus 8 is 7, plus 7 is going to be 0. So those answers both check out. Our second example here, as I look at x squared plus 6x plus 2, I'm going to look at that and I realize that the 2 is not a perfect square, so I need to come up with completing the square. So I'm going to set this equal to 0. So I have x squared plus 6x plus 2 is equal to 0. In order to do this, I'm going to subtract 2 from both sides. And that is going to give me x squared plus 6x plus some unknown quantity yet is equal to negative 2, plus or minus some unknown quantity. Now, again, I take my b term, which is 6, and I divide it by 2. You remember that from the Punnett squares yesterday? And when I do that, I get 6 divided by 2 is 3. That means that my factoring of x squared plus 6x as a perfect square would be x plus 3 quantity squared. We'll now take our 3 that we have, and we will square that term. And as we square that term, that will be 9. Therefore, the quantity of 9 is what completes our perfect square. X squared plus 6x plus 9 is the same as x plus 3 quantity squared. You can Punnett square that, and you'll see that. I added 9 to the left side. I must add 9 to the right side. That will then give me negative 2 plus 9 is equal to positive 7. I'll subtract 7 from both sides, and I'll have my vertex form at x plus 3 quantity squared minus 7 is equal to y. Okay? I can then write that there again. My vertex form is x plus 3 quantity squared minus 7 is equal to y. My vertex then, opposite sign of what's in the parentheses, so it's negative 3 as my x coordinate. Same sign as what is outside, that's my k value. That would be negative 7. So my vertex for this is going to be at negative 3, negative 7. So far, so good. Now we are going to go ahead and come up with a solution. Again, we set our equation, x plus 3 quantity squared minus 7 is equal to 0. In order to solve for this, I need to move 7 over to the other side, so I'll add 7 to both sides, and I get x plus 3 quantity squared is equal to positive 7. At this point, I need to take the square root of both sides, leaving me with x plus 3. And that's x plus 3 is equal to plus or minus the square root of 7. Now 7 is a prime number, so we're not going to be able to reduce that square root at all. So we're going to be left with now x plus 3 is equal to plus or minus the square root of 7. I'm going to subtract 3 from both sides, and I end up with x is equal to negative 3 plus or minus the square root of 7. That means I can have two solutions. X is equal to negative 3 plus the square root of 7 is one solution. Or the other solution would be x is equal to negative 3 minus radical 7. You could put those answers into a calculator. If you do put them into the calculator, x would be equal to negative 0.35, or x would be equal to negative 5.64. Okay. Decimal or radical number is fine, though I prefer the radical sign. Okay. Again, you could go through and make sure that x plus 3 quantity squared minus 7 graphs exactly the same as x squared plus 6x plus 2. And you could also find the zeros at negative 0.35 and at negative 0.564. In our third example here, same type of problem, x squared minus 2x plus 5 is equal to 0. Or maybe I should say equal to y. It's really okay either one for what we're doing right now. So my first step again, subtract 5 from both sides. 5 is not a perfect square. Okay. So I have x squared minus 2x, some quantity, plus or minus some quantity is equal to y minus 5, plus or minus some quantity that is unknown as of yet. Just like I've been doing, the negative 2, I'm going to divide by 2. And when I do that, I end up with negative 1. Thus, I know that what I'm going to square here, or my factor, my perfect square factor, is x minus 1 quantity squared. In order to complete the square, I need to take my b term that I've divided by 2 and square it. And when I do that, I end up with 1. So I need to add 1 to both sides of the equation. X squared minus 2x plus 1 is the same as x minus 1 quantity squared. You can check that by Punnett squaring that. And that's going to be equal to y minus 4. We're then going to add 4 to both sides. And this will get us into vertex form at x minus 1 quantity squared plus 4 is equal to y. Okay? So again, our vertex form, x minus 1 quantity squared plus 4 is equal to y, giving us a vertex of positive 1, the opposite sign there, and positive 4. Some of you will notice if this opens up and our lowest point is at a y value of 4, what would we anticipate? Well, the obvious thing we're going to anticipate is no real solutions. This graph here, just so we're aware, has a vertex at 1, 2, 3, 4. Which means its vertex is here, going through this point, and there'll be no x-intercepts. Which means we better have an I in my answer. Okay. Now, moving back to that. So now we take our equation, x minus 1, quantity squared, plus 4, set it equal to 0. I am then going to subtract 4 from each side, and I get x minus 1, quantity squared, is equal to negative 4. I will then take the square root of both sides, and I will end up with x minus 1 is equal to plus or minus the square root of negative 4. Continuing on, I have x minus 1 is equal to plus or minus the square root of negative 1, which will give us our I value, multiplied by the square root of 4. If I continue to work out this problem here, I get x minus 1 is equal to plus or minus I, which comes from here, the square root of negative 1, and multiplying it by 2 from the square root of 4. course, I can rewrite that as x minus 1 is equal to plus or minus 2I. Therefore, I'm going to add 1 now to both sides, and I get x is equal to 1 plus or minus 2I. Which means my two answers would be x is equal to 1 plus 2I. Obviously can't combine those as like terms. And x minus 2I. Or sorry, that's a mistake. So instead of that, let's back that up. That would be x is equal to 1 minus 2I. Okay? And those would be your answers. Again, two imaginary answers, or I should say two imaginary roots. And that's because, again, as we've mentioned, the vertex is above the x-axis. So we've already seen problems with real solutions and imaginary solutions. So we're going to work on this final one, x squared minus 4x plus 9. Now, I might encourage you to work on this on your own before you look at this. So I'm going to give you a moment to pause it and try it on your own. All right, hopefully I didn't just make a long, awkward pause there, but rather you tried to work on it on your own. And you're just restarting this video. All right. In order to make this vertex form, this is going to be equal to, we're going to set it equal to y. I could set it equal to 0. It's not really that much of a difference here. 9 is a perfect square. 4 is also a perfect square. So we might already have a perfect square here, but I'm not quite sure that 4 and 9 are going to work together. So we're going to subtract 9 from both sides. That's going to give us x squared minus 4x. So we're at x squared minus 4x, and then there is some quantity that we have to add or subtract to it, and that's going to be equal to y minus 9 plus or minus some quantity that's yet to be determined. Okay. Now, again, as we've said before, we're going to take our b term and we're going to divide it by 2. So that's negative 4 divided by 2, which gives us negative 2. So now we know that our factors of x squared minus 4x and whatever that unknown term is of yet, the factors of it are x minus 2 quantity squared. So we're going to go ahead and write that down. In order to complete the square, we're going to take our negative 2, we're going to square it, and when we do that, we get positive 4. So to complete the square, we're going to add 4 on the left side. That means that x squared minus 4x plus 4 is a perfect square, and that factors into x minus 2 quantity squared. Again, as I've said before, you can go check it out by doing a Punnett square. We add 4 to one side, we must add 4 to the other side, and that's what we're going to do. So we now get x minus 2 quantity squared is equal to y minus 5. At this point, we then add 5 to both sides of the equation. Again, we don't add it to anything in the parentheses because it's really not x minus 2. It is x minus 2 quantity squared. That's going to give us a vertex form of x minus 2 quantity squared plus 5 is equal to y. From that, our vertex, we're going to take the opposite sign of what's inside the parentheses. So instead of having negative 2, we'll have positive 2. It's the same sign as what's outside the parentheses for our y value, positive 5. Again, if you want to confirm, go ahead into your calculator, type in y equals x squared minus 4x plus 9, and type in y2, x minus 2 quantity squared plus 5. If you go to the table, y1 and y2 are identical. And you know you've done this problem right so far. If not, go ahead and resolve it. Okay, now we're at our solution. So, x minus 2 quantity squared plus 5 is set equal to 0. To find our zeros, we're then going to subtract 5 from both sides. And look what we're going to get. X minus 2 quantity squared is equal to negative 5, which of course we already should have known. It's going to open upward. Our y value, our minimum y value is at 5, which means this thing will always be above the x-axis, which means it can't touch it. which means 2 imaginary roots. Okay, so let's take the square root of both sides like we've been doing. We're going to end up with x minus 2 is equal to plus or minus the square root of negative 5. All right, at this point we recognize that 5 is a prime number, so we're going to have x minus 2 is equal to plus or minus I radical 5. And we can't further reduce radical 5 at all. We pulled out the I, the negative goes away. All we have to do now is add 2 to both sides of the equation. And we get x is equal to 2 plus or minus I radical 5. We can't combine any more terms there, and it doesn't really matter to split them up. You could, getting x is equal to 2 plus I radical 5 as one of your solutions, and x is equal to 2 minus I radical 5 as your other solution. Okay, your assignment's on Canvas. Go ahead and do that. And if you have any questions, you can send me a message in Canvas. And good luck on your homework. Have a great weekend.